Good morning. Lesson 2-1, percent of change. So we're going to use more proportional relationships in this module to solve percent of change problems. So percent of change is a ratio written as a percent which compares the change in quantity to the original amount. There can be increase and there can be decrease, or how much it changes up versus how much it changes down. And we're going to skip that part because I don't like the way it teaches that. Let's go here to method 2, which also I'm not going to have you do. I'm going to show you, I think, the way that will help you moving forward in math. So I'm on page 65. So the original problem said the enrollment in middle school increased from 650, the original amount, to 780 after 5 years. So you need to find the difference here. The difference is the answer when you subtract. So if you subtract 780 minus 650, you're going to get 130. So we need the difference, which is 130. Then you want to divide the difference by the original amount. The original amount was 650. Or what they started with. Then divide those. 130 divides 650 equals 0.2. But then remember, from 6th grade, to get this to a percent, you need to multiply by 100. 0.2 times 100 is 20. This is 20%. The difference divided by the original, then find that number as a percent by timesing it by 100. So let's try the check doing that method. A certain brand of shampoo contains 12 ounces in a bottle, original. The company decides to redesign the shape of the bottle. The new type of the bottle contains 15 ounces. What is the percent of increase in the amount of shampoo in the new bottle? So first we need to find the difference. Remember, if I write, you write. Then we're going to divide it by the original. Okay, so the difference is 15 minus 12. The original is 12. 15 minus 12 is 3. 3 divided by 12. 3 divided 12 equals 0.25 times 100 gets you to 25%. Okay, well, biscuits. Sorry. 25% increase. The difference, 15 minus 12 was 3, divided by the original 12. 3 divided by 12 was 0.25. 0.25 times 100 is 25%. Difference divided by original. Difference divided by original. All right, this check. Page 66. Frankie calculated that she would need 9.5 yards of wallpaper to decorate her room. The wallpaper she chose had a large pattern, so instead she needed 13 yards. So we started at 9.5. Original. 9.5. The difference is going to be 13 minus 9.5. 13 minus 9.5. Oh, biscuits. I did the wrong number. 13 minus 9.5 is 3.5. So we have 3.5 divided by 9.5, which equals a mess. 0.368421, blah, blah, blah. But look, rounded to the nearest percent. When they say nearest percent, they mean whole number. So 0.3684, and then we times that by 100, times 100, 36.8. The 0.8 makes the 6 go up to 7. 8 makes the 6 go up to 7, so it's really 37%. The difference divided by the original, and then see how accurate they want you to be. And guys, that's honestly how this whole lesson is going to go. I'm over on page 68 on the check. When resting, a spring measures 73.3 meters. Original, 73.3. When the spring is compressed, it measures 51.29. The difference between those two, 73.3 minus 51.29. 73.3 will stay on the bottom. Then we can subtract those. 73.3 minus 51.29 equals 22.01. The difference divided by the original. Find the percent of decrease the length of spring, round to the nearest percent. So round to the nearest whole number. So we're going to take our 22.01, divide it by the original, 73.3, and we'll get 0.3002, 0.3002, and then we're going to times that by 100, and then want it rounded to the nearest whole percent. 30.0 rounds to 30. Answer in a box. Difference divided by original. Okay, that should be enough to get you going. Good luck.